In this lecture we will discuss about deviation by successive reflection at two inclined mirror. So let us say we have two inclined mirror and they are inclined at an angle of theta. So these are two plane mirrors. A light ray is incident on the first mirror and it gets reflected by the first mirror and then again incident on the second mirror. By the second mirror again it gets reflected. We have to find total deviation of this ray by two successive reflections. So this is first reflection and here we have second reflection. So our task is to find total deviation by two reflection. Let us say the first angle of glancing is alpha. So the angle made by the contact surface, that is the plane mirror, and the incident ray is called glancing angle. Angle between plane surface, in this case plane mirror, and incident ray. Now we know if this angle is angle of incidence, then this is angle of reflection. So from law of reflection we know that I is equals to R. This means this angle is again alpha, because this is I plus alpha, then this also equals to be I plus alpha. I is equals to R, then this angle has to be alpha. So ray will emerge this side by making angle alpha with the plane surface. This is the incident direction of ray. What is the deviation? This is the deviation of ray. Basically ray wants to go in this direction, but it has been bent in this direction. Let us call this deviation is d1. So we can find deviation by the first mirror. So let us call this is mirror OX, this is mirror OY. This deviation is, if this angle is alpha, then this angle is also alpha, because this angle and this angle is opposite angles. So this angle is also alpha because it is opposite angle. So we can say total deviation is alpha plus alpha, that is 2 alpha, and this deviation is in this direction, that is we have clockwise deviation. Basically this can be remembered as a result whenever we have a light that falls on a plane surface with a glancing angle alpha. After reflection it will deflect through, or it will deviate through, a angle of 2 alpha. So in this case this angle is alpha, this angle is also alpha, and this angle is also alpha, so total deviation is 2 alpha. So whenever we have a light that incident on a surface with glancing angle alpha, it will deviate through 2 alpha. Now let us consider the second case of reflection. Now let us say this ray is glancing this plane surface at a angle of beta. So this is glancing this plane mirror at a angle of beta. So what is the total deviation for this ray? This ray will deviate in this direction with a angle of 2 beta, because we have proved that if angle of glancing is alpha, then deviation is 2 alpha. So we can say deviation by the O by mirror, and this is equals to 2 beta. Now direction is this. So this is anti-clockwise, because in this case this is deviating in anti-clockwise direction. So this is anti-clockwise. So we can basically add these deviation to get the total deviation of this ray. So we can write total deviation this will be 2 beta. So we are taking anti-clockwise direction as positive, then clockwise will be negative, so 2 beta minus 2 alpha, and this is in anti-clockwise direction, that is we will have this direction. Now we can find what is the value of beta minus alpha. Now if I use this triangle, let us call this as MON. So if I use triangle MON, we can say angle alpha plus angle theta is equals to angle beta, because this is the exterior angle and these two are interior angle. So sum of the interior angle is equals to exterior angle. So in triangle MON, we can say sum of the interior angle is equals to exterior angle. So we will have in this case beta is equals to alpha plus theta. So beta minus alpha is equals to theta. Let us say plug this value in equation 1. We will have total deviation or net deviation is equals to 2 into beta minus alpha, and beta minus alpha is nothing but theta. So this is 2 theta, and theta is angle of inclination between two plane mirrors. So we can say whenever a ray makes two successive reflection, net deviation is twice the angle between mirrors. So we can say in two successive reflection is 2 times angle between the mirror. This result is also true if the second ray deflects in this direction. So let us say if I have the same mirror, so this is OX, this is OY. So this is the incident ray after first reflection, and then we have second reflection. We can make something like this. So this is the first reflection, this is the second reflection. These are two plane mirrors, OX and OY. You you see the difference in the first case, after second reflection, light is bending in this direction, that is right side. But now in this case it is bending towards left side. Let us say glancing angle first is alpha and glancing angle for the second plane mirror is beta. So in the first case deflection is, so light ray wants to go in this direction, it will deflect in this direction. Let us call deflection is d1. So this is equals to 2 times glancing angle, that is 2 alpha. So we can say deflection by first mirror this is equals to 2 alpha. Now this deflection is clockwise. Now let us see for the next mirror, the second mirror. Basically ray has to go in this direction, but now it is deflected in this direction. So this is deflection d2 and this is again equals to 2 beta. So deflection by the second mirror, this is equals to d2 and d2 is equals to 2 beta. And this is also in clockwise direction, so this deflection is also in clockwise direction. So we can say total deflection of ray this is equals to 2 alpha plus 2 beta, that is in clockwise direction. Now we can use triangle. Angle between mirror is theta and this angle is alpha. So we can write in this triangle, let us call this as OMN. Alpha plus beta plus theta is equals to pi. So in triangle OMN, we can say alpha plus beta plus theta is equals to pi. This means alpha plus beta is equals to 2 pi minus theta. So we will have total deflection or deviation, more correctly it is deviation, this is equals to 2 times alpha plus beta, that is 2 pi minus 2 theta, that is in clockwise direction. Now 2 pi minus 2 theta in clockwise direction is same as 2 theta in anti-clockwise direction. So let us say this is the angle in clockwise direction and this angle is 2 pi minus 2 theta. If I measure the same angle in anti-clockwise direction, this angle is 2 theta because sum of this angle and this angle is equals to 2 pi. So 2 pi minus 2 theta in clockwise direction is same as 2 theta in anti-clockwise direction. So this means whatever with the configuration of mirror or whatever with the incident ray position, it will always be 2 theta. So deviation by the two successive reflection is always equals to 2 theta in anti-clockwise direction. So deviation by two successive reflection is always 2 theta, where theta is the angle between mirror.